Hi everyone, I want to move on to our final form. So we should know how to get information about a quadratic when it's written in standard form, ax squared plus bx plus c, in factored form, or in vertex form, which is this one right here. So we won't always be given the equation in vertex form. We can get it there by completing the square if we need to. But I actually would say, so we're definitely going to practice that. What's really important to me right now is once it's in vertex form that you understand that you get some really good information from that. So the A, as usual, tells you if the graph opens up or down. Just think about this. If we multiplied this out, x squared minus 2xh plus h squared plus k. This is supposed to be squared. There we go. You'll get an ax squared. So the a, it doesn't just mean the same thing. It is the same thing. If you multiplied it out, it would still be the number in front of x squared. So a tells you opens up, opens down. And if a is bigger than 1, it's going to be taller and skinnier than x squared. And if it's between 0 and 1, it'll be shorter and fatter than x squared. Okay, the really important thing is that when you write it in this form, this number here and this number here tell you exactly where the vertex is. So we'll get into this a lot more in a 141, but basically if you can get it written in this form, the h is telling you if you picked up x squared, how far you'd have to move it left or right to get the graph of this new function. And the k is telling you if you pick up x squared, how much you'd have to move it up or down to get the graph of this new function. So for us, we just want to remember that hk are the coordinates of the vertex. Pay attention to the fact that there's a minus built in there. That makes it a little tricky. Whatever number is in those parentheses, so if you had x minus 3 squared plus 2, that has a vertex at 3, 2. If you had x plus 4 squared minus 5, that has a vertex at negative 4, negative 5. So the k is exactly how it appears. The h is the opposite of how it appears. So it's a little tricky, and you're just going to have to remember this would be another good flashcard thing. Okay, so to find the x-intercepts, you're just going to have to do the work, set it equal to 0 and solve. It is going to be nicely set up for using square roots to solve, so that's kind of handy. And to use the y-intercept, you're just going to have to plug 0 in and figure out what you get. It's really tempting to want to say k is the y-coordinate of the y-intercept, but it's not. It's the y-coordinate of the vertex. Okay, so let's start with one that is in vertex form and get the information off of it. And then I'll also do one that's in standard form and show you how to rewrite it in vertex form by completing the square. So it's the same trick, but looks just a little different again, so we'll work through it carefully. Okay, so y-intercept, I already see, I switched to t, so that should be t down there. To get a y-intercept, you let your x be 0, or in this case, your t be 0. So in the parentheses, we're just going to get negative 1. And notice that 2 is not going to be my y-intercept. I'm going to have 1/2 times 1 plus 2, which is 2.5, or 5/2. So 0, 5/2 is my y-intercept. My t-intercept, to find that, you have to set the whole thing equal to 0. And again, pay attention here. This one is really nicely set up to solve using square roots. So I'm going to subtract 2. And then I'm going to multiply by 2. And I'm actually running into trouble again where I can't square root a negative 4. So this has no zeros, no x-intercepts, no zeros, no roots. Those all mean the same thing. So we don't get to cross the x-axis. Okay, so then the only thing we have left to work from is the vertex. And since this is in vertex form, you do not need to multiply it out. You can read straight off of there. If I have a t minus 1, that means the x coordinate of the vertex is positive 1. And if at the end I have a plus 2, then the y coordinate is positive 2. So change the sign in the parentheses. Don't change the sign at the end. Okay, so let's try and put this together. 1, 2, and 0, 2.5. Okay, so we don't need a real big scale. 1, 2. This is my vertex. And then my y-intercept is 0, 2.5. And I know that this had a positive 1/2 out in front, so it's going to open up and it's going to be kind of wide. So I can get a pretty good rough sketch even just with 2 points. Generally for parabolas we like to have 3. 2 points is enough to draw a line, but 3 points are needed for parabolas. So I'm just going to go ahead and plug in, I don't know, let's plug in 2. What was my function? M of 2 is equal to 1/2 of 2 minus 1 squared, so that's just 1 squared, which means 1/2 times 1 plus 2. Oh, and actually not surprising, I could have used my symmetry for that as well. This is my vertex, so that's my axis of symmetry, which means if moving over 1 gives me a y-coordinate of 2.5, then moving 1 the other way should also give me a y-coordinate of 2.5. So points that are equal, or points that have the same y-coordinate should be equal distance from the middle, that axis of symmetry. Okay, so there's my sketch. Thanks for watching.